All right, so we got a new topic this week. We're talking about simplifying radicals, and when we're simplifying radical expressions, we have a couple of things that we need to talk about in terms of definitions. So this symbol is called a radical symbol, and then underneath the radical symbol will be some kind of letter or number combination, and what's underneath it is called the radicand. The radicand is the number or number-letter combination that is underneath the radical. We don't see a number over here, but this, when we don't see a number here, we know that that is called the square root. But there could be a number up there, and if there is a number up there, that would be called the index. And the index tells me what the root is. So since there is no symbol there, it's a square root. But if this had a 3 up here, this would mean the third root. So a square root means a number multiplied by itself gives me the number underneath. The third root means a number multiplied by itself 3 times would give me that. So like the square root of 16 is equal to 4 because 4 times 4 equals 16. Well, the third root of 8 equals 2 because 2 times 2 times 2 is equal to 8. And so this index tells me that I'm looking for a number multiplied by itself 3 times that gives me that. When there's not a number, we know that that's called a square root. So you need to know the first 10 perfect squares. So the first 10 perfect squares. You should probably know 11 and 12 as well, 13, But square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10. You should also try to memorize through 15. So you should know the square root of what is equal to 11, the square root of what is equal to 12, the square root of what is equal to 13, the square root of what is equal to 14, and the square root of what is equal to 15. Now if you know these, fantastic. If you don't, that's all right. The square root of what is equal to 11? So 11 times 11 is 121. So the square root of 121 is 11. And so 12 times 12 is 144. So therefore the square root of 144 is 12. 13 times 13 is 169. So the square root of 169 is 13. The interesting thing here is this is the same numbers as that. They're just reversed. It's 196. So the square root of 196 is 14. And that's how, when I was younger, I remembered those, right? Square root of 169 is 13, but if I switch those, 196 is 14. And then 225, square root of 225 is 15. So you should have already memorized 1 through 10. If you haven't, then you need to commit that to memory. I'm just adding these because, this is Math 4, so we should be able to push ourselves a little bit further. So we need to simplify square roots, and we're going to simplify using the perfect square method. So the perfect square method is when I know that the square root of 1 equals 1, the square root of 4 equals 2, the square root of 9 equals 3, the square root of 16 equals 4, the square root of 25 equals 5, and so on. So I look at 12, and are there any numbers on this list over here, any numbers there that go into 12? Well, I know that 4 goes into 12. So this is 3 times 4. And I have broken 12 up to factor it. So 12 factors to 3 times 4. Well, I know 4 is a perfect square. So this is actually the square root of 3 times the square root of 4. But the square root of 4 we know is equal to 2. So this is the square root of 3 times 2. And we write that as 2 times the square root of 3. So the 2 goes out front, and then the square root of 3 goes behind. So the square root of 12 simplifies to 2 times the square root of 3. All right, we're going to simplify the square root of 20. So 20, what are the factors that go into 20? So remember, we want our perfect squares if we can remember what those are. And we know that 4 goes into 20, and 4 is a perfect square, so this is 4 times 5. Factors of 20, 4, and 5. And the square root of 4 is a perfect square, which is 2. So this is going to be 2 times the square root of 5. And that's how you simplify with square roots. Now notice this number got real big real quick. And so it might not be easy how to break it down. And maybe you don't know what to break it down to. So whenever I see a number like this, I want to break it down into smaller pieces that are easy to deal with. So 4 goes into it, but I don't think that's common knowledge. Like I think it would be hard for you to look at this and say, oh yeah, 4 goes into it. But I think most people can say that we see that 10 goes into it because it ends in a 0. So this would be 14 times 10. And then I can break down 14. 14 is 7 times 2. And 10 is 2 times 5. Well, notice I have 2 times 2. And we know that that's 4. So this is 7 times 4 times 5, and there's my perfect square. So what I'm going to do is rewrite this as the square root of 4 times the square root of 7 times 5. The square root of 4 is 2. We can't simplify this any further, so this 7 times 5, we're going to multiply that out, and that's the square root of 35. So 2 times the square root of 35. So the square root of 140 simplifies to 2 times the square root of 35. And there's other ways to do it, but I think this is a way that is, when we recognize that 10 goes into it, we can break it apart, and then we can put things back together that are going to give us a perfect. I'd like you to pause the video and take a minute to try these on your own. All right, so pause the video and try these on your own. All right, now that you've paused it, this is square root of 44. Hopefully you recognize that this is the square root of 4 times the square root of 11, and that's going to be 2 times the square root of 11. 64 is on our list, right? That's one of the perfect squares already, so the square root of 64 is 8, and that could be easy. 56, a little more challenging. I think that you might recognize that that's 7 times 8, and now 8 breaks down again. 8 can break down to 2 times 4, so we have the square root of 7 times 2 times 4. But we're looking for the perfect square underneath. 4 is a perfect square, so we know that that's going to come out front. So let's show this. The square root of 4 times the square root of 7 times 2. Well, the square root of 4 is 2, so that's 2, and then 7 times 2 is 14. 2 square root of 14. So that would be my final answer. It might not take you that many steps to do that. You might have recognized that 4 went into it initially and had it down as 4 and 14, but this is breaking it down. And then we have square root of 250. I think before we talked about having a 0 there, we have a 0, we know that 10 goes into it, so this is the square root of 25 times 10. Well, the thing about 25, that's one of our perfect squares. So we have the square root of 25 times the square root of 10, which is 5 square root of 10. All right. Here's some other ones. Take a minute, pause the video, try these on your own. Great. Now that you did that, 18 breaks down to 9 times 2, and square root of 9 is 3, so 3 root 2. Square root of 288, this breaks down to 144 times 2. Square root of 144, as we already went over, is 12, so this is 12 times the square root of 2. 75, hopefully you recognize that that's 25 times 3, which is 5 square root of 3. 24 is There's lots of ways to break 24 down, but I think the most meaningful way for taking the square roots is 4 times 6. Since we know the square root of 4 is 2, so we get 2 square root of 6. Then 72 is, well, there's a couple different ways to do this. If you recognize it's 36 times 2, and then you know the square root of 36 is 6, I think most people will probably recognize that this is 9 times 8. And then 9 times 8, the 9 is a perfect square, but 8 can be broken down more, so that's a square root of 9 times 4 times 2. And the square root of 9 is 3. Square root of 4 is 2. So now there's two things I'm taking out there. I multiply them. So this is going to be 3 times 2 square root of 2, or 6 square root of 2.